Where are the electrons in an atom? This is going to be a quick review of quantum numbers, electron configuration, orbital notation, highest occupied level, valence electrons, etc. Remember that the electrons in an atom are actually, like, the nucleus is really small, and the electrons are in the electron cloud, which is the region surrounding the nucleus. And that we said that those electrons actually occupy orbitals, and that the orbitals are specific shapes or areas of three-dimensional space where the electrons are most likely to be found. So if we're going to start with the electron configuration of sulfur, you either need to use your diagonal rule or you need to have memorized the order that the electrons fill in. You know, the 1s, then the 2s, then the 2p, the 3s, the 3p, the 4s, the 3d, the 4p, etc. And you should be able to fill them all the way up through the 7p for the test. So sulfur, we look on the periodic table and it has 16 electrons. And so we start in the 1s, and we can put 2 electrons in the 1s, so we do 1s2. Then we have the second energy level, and we can put 2 electrons in it. So we've used 4 electrons, so that means that we have, let's see, 16, minus 4, 16 minus 4 is 12, so we have 12 left. So then we have the 2p, and we can put 6 in the 2p, so we've used up 6, so we have 6 electrons left. So now we have the 3s, and we can put 2 in the 3s. Just disregard that part. Alright, the 3s2, so we've used up 2 electrons, so we have 4 left, so then we'll do the 3p4. So this right here is our electron configuration for sulfur. If we wanted to quickly do the quantum numbers, we could take, even though it's an electron configuration, we know that the 3p has 4 orbitals. So I'm going to erase all of this so that I have more space. Alright, so the 3p has 3 orbitals, and we know that there are 4 electrons in the 3p. Alright, so there are 4 electrons, so we're going to go up. Wait, why won't this go up? Oh, here we go. We're going to go up, 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 and then down. Alright, so that means that N is going to be 3, because we get it from right there. So N is 3. That's the N. Our L comes from the P value. So remember, we have that L can be 0, 1, 2, or 3, which is S, P, D, or F. So P is 1. That's going to be our L. So that's 1. M sub L is going to be, it would be 0 if we were in the middle one. So this one over to the side is -1. And then M sub S, it's the down arrow, so it's -1/2. So that's how you do the quantum numbers on an electron configuration if you don't already have it in orbital notation. Brings us to orbital notation for silicon. And to do the orbital notation for silicon, we do it similar to the electron configuration, but we're going to actually draw out the orbitals. So silicon has 14 electrons. So we start in the 1s, and we draw a line to represent the orbital, and we can put 2 electrons there. We might have to move this down a little bit. Alright, so we draw a line, 1s, and put 2 electrons there. Then in the 2s, we can put electrons. And then in the 2p, there are 3 orbitals. So we'll go ahead and draw out all 3. We draw them out regardless of whether or not we use all of them. So we've used 4 electrons, so that means we have 10 electrons left. So we're going to go 1, 2, 3, 4, 5, 6. So now we've used 10, so there are 4 left. And I would recommend that when you're doing something like the 2p, that you go up, 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 then come back and go down, 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 just to get into the practice of filling them in the right order. So we have used 10, so we have 4 left, so we can put 2 in the 3s. Then we have the 3p, so we draw out all 3 orbitals of the 3p, and then we have 2 electrons left because we've used 12. So the first one goes here, and the second one goes here. All right, now if I asked you to do the quantum numbers for the last electron filled, that's this guy right here. That's this guy right here. And so we would say N is 3. That comes from right there. We'd say L is going to be 1, and that's from the P value. Because remember on the last slide I showed you where 0 is S, P is 1. All right, M sub L comes from the values of the actual orbitals. So this would be 0, -1, +1. So this is in the 0 orbital. And then M sub S is going to be +1/2 because the arrow is pointing up. So it'll be +1/2. So that's our 4 quantum numbers for the orbital notation. Now, if we want to do highest occupied level, valence electrons, inner shell electrons, and electron dot notation, let's take boron. Ooh, let's leave that there. Boron has 5 electrons. And so its electron configuration would be 1s2, 2s2, 2p1. So my highest occupied level is going to be 2, because I look for what my highest N value is. My valence electrons are going to be all the electrons in that occupied level. So here I have 2 from the S plus 1 from the P, so I'm going to have 3 valence electrons. And then my inner shell electrons are going to be my total, which is 5, minus my valence, so I get 2 inner shell electrons. And then to do the electron dot notation, I take my symbol, B, and then I put a dot for each valence electron. So dot, dot, dot. And you want to make sure that they line up kind of like they're in a square around the element. No more than 2 per side. All right, so that's the basic overview of the quantum numbers, electron configuration, orbital notation, and then the stuff you need to be able to do with that.